This is going to be a fun one. I've generated actually a Stormtrooper image in black and white, and we're going to pass multiple different image filters over that in order to kind of expose the before and after, and how these different image filters will actually modify the image. So again, just going to expose you to different image filter types. There's averaging filters, there's edge filters. Laplacian is like a sharpening filter. So we're going to have everything from blurring to sharpening, and how you detect edges within this simple image that I've implemented within Excel. Okay, so here we go. How you actually read this is, I'm going to put the cursor up in the upper left-hand corner, but on the left-hand side is the original image. So this is the Stormtrooper image that I've created. If you actually, pass over, let's start here, kind of in the center. So if you look at the value, it's a 0. I have used conditional formatting with a white to black scale or shading. You look, there's some gray pixels in here. When I go down and scroll over them, it says 0.25. So we have 0 as white, 0.25 as gray, and then black as 1. So these are the 3 different pixel values that I've used in creating this Stormtrooper image. In the center kind of console here, these are different types of edge filters, different types of image filters. We have an average, a Gaussian, and you can see the different values that I've used within these different filters to just show how these different filters modify the original image. I then have this drop-down menu where I can actually select these different filters. Right now I have it on the custom filter, and it will select from these different filters down below, and we'll place it into this applied filter box. And that's actually the filter that's going to operate on the image to the left. After it operates on it, it's going to return, well, this is what the image looks like after we've convoluted it with this filter. So there we go. Here's the custom filter. If I just have a 1 in the center of a 3x3 filter, it's just taking the center pixel within each 3x3 region and multiplying that by 1. Since 0 times all the other surrounding pixels is 0, it's going to return you the exact value that you started with. Notice that this will actually scale between the minimum and maximum pixel value, so it may not always be exactly a 1-to-1 match. For instance, if I took this custom filter and made it 10, this would multiply every value in here by 10. So you saw the 0.25, it's rounding up to give it 3, but the image hasn't changed because it's actually the conditional formatting, grayscale, color scale, is actually shifting with the min and max pixel values. So let's put this back to 1. If I chose -1 in that middle pixel, it's going to inverse it. So now what we have is where we had a 1 and black in the original image, that is actually -1, so it's now the minimum pixel value, so it is turned white, whereas 0 multiplied by -1 is 0, and that's actually the maximum value now. So it's inverted the whole image whenever there's a negative. But let's shift that back. Actually, we're going to put it as 0 now. So that actually blocks everything out. If I put a 1 off to the side, So you notice that within this filter, I've put a 1 over towards the left-hand side. It's actually shifted the whole image over. So I can choose 0. If I put it on the opposite side, it shifts it the opposite way. So just trying to warm you up to what the different values within these images do. So I can place 1, 1, 1, and it's going to blur it, but only within this one dimension. So again, this custom is actually closer to what you're going to get with convolutional neural networks, which won't look like the traditional image filters. Again, it's training these different parameters as independent parameters, and it's bumping them up or down in order to make the final prediction match what it was trained on. So let's start to shift through some of these filters and see how it affects the initial image. An averaging filter, again, here you see how it's kind of blurred these regions because it's not only taking the pixel where it's determining the new value, but it's grabbing all the pixels around that, and it's weighting them equally. And so the effect that that has is to average it. If I go down to Gaussian, Gaussian is another type of, you could say a blurring, if you will. But if you look at the pixel values, there's a 4 in the middle. So it's more highly weighting the pixel that it's going to replace. It's then weighting the first nearest neighbors, if you will, a little lower than that. And the further you get away from that pixel, the lower the weight will be. So it is smoothing out the image, but it's also applying more weight to the original pixel value. If we do something like a vertical edge, so now it's looking for edges up and down, you can actually look at what the values are. There's a 1, 2, 1 over here, a -1, -2, -1 over there. So it's actually looking for, okay, where are their vertical edges? What's interesting here is if you look at this top horizontal edge, it doesn't detect that at all. But it does detect a lot of the vertical edges within the image. If we go to a horizontal edge detector, okay, now this is detecting, this top edge, as well as multiple others throughout the image. Can do diagonal edges where it's trying to detect, edges along the diagonal. And of course you can see over here off to the upper left where there was only these diagonal pixels in the opposite direction, and how this filter did not detect that. And again, you can do diagonal in the other direction, and it detects those diagonal edges as well. So you see some of this within convolutional neural net image filters, although it's a little bit harder to interpret exactly why it chose the values within the filter that it did. Another type of image filter is called a Laplacian or a sharpening filter. If you look down here at what the values are, or sorry, maybe it's easier up here, you see a 4 in the center, or you could even have something else there. So it's highly weighting the pixel that it's operating on, and the region surrounding that, it's actually negatively weighting those. And so it's actually forcing the pixel to essentially sharpen, within the image. And so you can see what the effect is here. Here's one type of Laplacian. Here's a second type of Laplacian, but you can see how it's kind of sharpening the image through affecting the contrast within that original image. As I'm looking here, it looks like we've kind of ran through the gamut of the different types of filters. And this will come up again as we look at convolutional neural networks and what these filters actually look like after training on some of these large image data sets. It's a little bit harder to interpret. That's where back prior to convolutional neural networks, digital image processing really leaned into these different types of image filters, in order to try to characterize where different features within the images are located, as well as trying to interpret, what type of image is this.